Hey, hi and welcome back. Now let's start with this video, which is about Introduction to Motor Driver IC. So now let me tell you what you're going to learn in this video. So the first point is Introduction to L293D Motor Driver IC. So L293D is basically the IC that we are going to use in our design to drive the motors. So I will discuss every single thing regarding this particular IC in this video. Okay. So the first point is about introduction. Then the next point is pin configuration. So as always, we are going to discuss the pin configuration and we will try to understand the significance of each and every pin which is present on this IC. Okay. Then the next point is functional diagram. So we will try to understand the functional diagram in order to understand the internal structure of this particular IC. Okay. So that's how basically we are going to cover this video and I hope that you will enjoy this video. Okay. So now let's start with this video. So this is how basically the L293D IC look like. And you know L293D IC is actually very old IC and still this particular IC is very popular when it comes to, motor driving related applications. So this IC is actually used for around 2 to 2.5 decades. So that much old this particular IC is, and there are different manufacturers which manufactures this particular IC. So Texas Instrument is actually one of the manufacturer. Then ST Microelectronics is another manufacturer. So likewise, there are different manufacturers which manufactures this IC. Okay. And although this particular IC was invented around 15 to 20 years back, but still even today, this IC is actually very popular when it comes to motor driving related applications. And that's the reason I have used this IC in our design. Because if anyone has to get started with the motor control related application, then he should actually start with this IC. He should understand this IC and then only he should go ahead. Okay. So this IC comes in DIP package, which stands for dual inline package, and it has got 16 pins. And again, this particular IC will be easily available in the local market. So if you want to drive the motors, you can actually purchase this IC from the local market and you can experiment. So you can see on the left hand side there are total 8 pins. In the same way, on the right hand side there are total 8 pins. And again, the pin configuration of this IC is very simple. So let's try to understand the pin configuration of this IC now. So here I have given the pin configuration table. I have taken this particular table from the data sheet of L293D IC. You can directly search for the L293D on the Google and you will get the data sheet of this IC. Okay. And one more thing I want to tell you, it's not like you should use this IC only when it comes to motor driver related application. There are a lot of ICs which are manufactured by different manufacturers. But as I told you, this is actually very simple IC and very popular and easily available in the market. That's the reason I have selected this IC in our hardware. Okay. So now let's try to understand the pin configuration of this IC. So I will start from this point, which is pin number 16. And the pin number 16 is actually VCC1 pin. And this particular pin should be actually connected to plus 5 volt. If you check the data sheet of this IC, you will find that the maximum voltage that you can provide to this particular pin, it's actually 6 volt. But in our case, as we are generating plus 5 volt with the help of 7805 power supply, so we are going to provide this voltage, in order to power this particular IC. And most of the time, you should use this voltage only to power the VCC1 pin. Okay. Then pin number 4, pin number 5, pin number 12, and then pin number 13. These are all the ground pins of this IC. Okay. So these all pins should be connected to the ground together like this. Okay. So these two pins will be connected to the ground. Along with that, these two pins also will be connected to the ground. So all the 4 pins will be connected to the ground. Then the next pin which I want to discuss is VCC2. So this pin is actually responsible for powering the motors or the load that you will connect to this IC. So VCC2, whatever voltage you will provide on this particular pin, if you provide 9 volt, then the motors that you will connect on this IC, those motors will actually run on 9 volt. If you connect 12 volt, then those motors will run on 12 volt. If you connect 18 volt, then those motors will run on 18 volt. So whatever supply you will provide on this particular pin of this IC, that supply will be actually used to drive the motors. Okay. So I hope that this point is now clear to you, and same thing you will actually get, in this pin configuration table. Then after that, if you see here, there are actually 4 drivers in this IC. Okay. So when I will show you the functional diagram of this IC, at that time you will, it will be actually more clear to you. But at this point, just remember there are actually 4 drivers in this IC. So this is the output of driver and this is the input of driver. And this pin, or the input side should be connected to the microcontroller or the device through which you are actually controlling this IC. In our case, it's microcontroller. So we are going to connect this particular pin to the microcontroller's GPIO pin. Okay. So if you provide logic 1 here, then the supply voltage will be actually available on this particular pin. If you are using a supply voltage as 12 volt, then 12 volt will be available on this pin. If you provide logic 0, then 0 volt will be available on this pin. Okay. In the same way, as I told you, there are 4 drivers in this IC. So this is the input and output of first driver. Then this is the input and output of second driver. So this is the input of second driver. This is this input of second driver. Then this is the output of second driver. So again, if you provide logic 1 here, then at this point you are going to get 12 volt. And if you provide logic 0, you will get 0 volt here. Okay. So likewise, this is the third driver, and then this is the fourth driver. Okay. So we are done with almost all the pins. Now we are just left with this pin, which is pin number 1 and pin number 3. Now let's try to understand the purpose of these 2 pins. So as I told you, there are total 4 drivers. Now if you want to enable these 2 drivers, the first driver and then the second driver, then this particular pin, which is pin number 1, it should be actually, there should be logic 1 on this pin. If you provide logic 0, on this pin, then no matter whether you provide logic 1 here or logic 0, the 12 volt or 0 volt will not be available on this pin. So if you provide logic 1 on this pin, then only this first driver and the second driver will be enabled. Otherwise, if you provide logic 0, then these 2 drivers, first and second, will be disabled. And then the same thing is actually true for this particular pin, which is pin number 9. So this pin, logic available on this particular pin will actually decide whether the driver 3 will be disabled or it will be enabled. Okay. In the same way, logic available on this particular pin will decide whether this particular driver will be enabled or disabled. Okay. So we are done with all the pins. I hope that the functioning of all the pins is now crystal clear to you. And now you are much confident about this particular IC. Okay. So now let's go ahead. So this is basically the functional diagram of L293D IC. And you can see, as I told you, there are actually 4 drivers inside this IC. So pin number 3 is the output of this first driver. Then pin number 2 is actually the input of this driver. Okay. And as I told you, this pin will be connected to the GPIO pin of the microcontroller. In the same way, this is the input pin of this driver. This is the output pin of this driver. This is the input pin. This is the output pin. And again, this is the input pin. And then this is the output pin of this driver. Okay. And you can actually use all these 4 drivers individually also. For example, if there is a lamp, okay, if there is a lamp, or if there is a light, or if there is a LED which actually works on, let's say, 12 volt. So what you can do, you can connect the anode terminal of that particular LED to this particular pin, which is pin number 3, which is output of driver, and then the another terminal, which is cathode terminal of that the LED, you can actually connect to the ground. So likewise, you can actually connect 4 LEDs of this type with you can actually drive 4 LEDs of this type with the help of this motor driver IC. So it's not like you can only use this IC to drive the motors. You can also use this IC to drive the LEDs. Okay. But you have to make sure you have to consider the voltage as an aspect, because if you are using the LED with only 2.4 volt and if you are providing 12 volt on the VCC2 pin, then that particular LED will get damaged. Okay, so that care you have to do. And whenever you have to drive the motors, this is how basically the configuration is going to be. One terminal of the motor will be connected to the output of one driver, and then the another terminal of the motor you have to connect it to the output of second driver. And even if you don't connect these diodes, still the circuit will work properly. Okay, these are actually called as flyback diodes, or they are also called as freewheeling diodes. So there are actually different names for this diode, and these diodes are actually used to protect the pins of the of this particular IC. Like this is the pin number 3 and pin number 6. These pins can actually get damaged if you are using a high load motor here, because when you stop the motor, the shaft of the motor is actually going to rotate. Still it will keep rotating, and as a result the reverse current can actually flow towards the pin of the L293D, and that reverse current, if it is too high, then that may actually damage the pins of this particular IC. But if you are using the freewheeling diodes or flyback diodes, then instead of going the current towards these pins, that current will actually travel towards the ground. Okay, so based on the rotation of motor, it will be decided which two diodes will be enabled. Okay, so if it is rotating clockwise, then if let's say that the current is like this, when the motor is stopped, then this diode will conduct. Okay, and along with that this particular diode will conduct. Okay, so the current will go like this, then through this diode, and it will actually go towards the supply. Okay, so that's basically the purpose of these freewheeling diodes or flyback diodes. Okay, and in the same way, if the motor is rotating in anti-clockwise direction, and if the current is like this, then this diode and this diode will actually conduct. Okay, so like this, the current will flow through the ground, then towards this motor. Okay, and that's how basically these diodes are used to protect the pins of the L293D IC. But in our case, we are not using these diodes. The reason is the motor that we are using, it's not going to consume much current. Okay, it's actually going to consume the current less than 50 milliampere. We have already discussed that, right? So when we discussed the power consumption calculation. Okay, so the current consumption of the motor that we are using, it's actually very less. That's the reason even if you don't connect the diodes, it's completely fine. So I hope that every single thing that we discussed regarding this L293D IC is now clear to you. And if you still have any kind of doubt, then definitely you can reach to me and I will help you with that. Okay, so now I will see you in the next video, which is about understanding circuit of motor driver IC. So I will see you in the next video now.